All right, so this last section is how to use trigonometric functions in applications. So as of now, our application problems will look like right triangles because right now we only know right triangle trigonometry. All right, so number 6 says a forester 300 feet from the base of a redwood tree observes that the angle between the ground and the top of the tree is 45 degrees. Determine the height of the tree. All right, so in order to see how this problem should be solved, we need to draw a picture, and in our picture we should see a triangle pop up. Okay, so I just like to go through the problem and draw what I read. So we have a forester, someone who works in the forest. Again, you will note that I am not a great artist. All right, this forester is 300 feet from the base of a redwood tree. So this person is 300 feet from the bottom of some tree. All right, the person observes that the angle between the ground and the top of the tree is 45 degrees. So here's the person on the ground, and he says the angle between the ground and the top of the tree is 45 degrees. All right, so if I were to make a line from here to the top of the tree, this would be my angle. And they say it's 45 degrees. And then we want to figure out how tall is our tree. Well, here's our H right here. And what shape does this make? A right triangle. This is perfect for us. Okay, so we have to determine the height of a tree. All right, we're given an angle. We have a right triangle, so we have to figure out what function can we use. Well, it should probably be a trig function. Okay, and so let's think about how we define our trig functions with side lengths related to our angle. So where 300 is the adjacent side of our triangle and the height is the opposite side of our triangle. So do we have any trig functions that deal with adjacent and opposite? All right, so if we go through our list, which ones deal with adjacent and opposite? That would be tangent and cotangent. So that means we should be able to find tangent of 45 degrees is opposite, which is our H, over adjacent, which is 300. Now we can solve for H by multiplying 300 on both sides. And what is tangent of 45 degrees? Well, that's something we've already found today. Tangent of 45 degrees is 1. So the height of the tree is 300 feet. Okay. All right, and then, so you can also put this in the calculator to figure it out. So I do want to point something out. Notice that our angle here is given in degrees, so that means that our calculator needs to be in degrees as well. So I can work this problem as long as my calculator is in degrees. I'll show you how to change it from degrees to radians. All right, so if you hit the mode button, and it's right on degrees, just move over to radians. And then that changes our calculator to radians mode. But we want to be in degrees for this problem, and I'll show you what happens if you're not. So we want 300 times tangent of 45, and we get 300. All right, so why is it important that our calculator is in degrees when we're working with degrees? Well, if I put this in radians and did the same thing, 300 times tangent of 45, oh, I get the wrong answer because this is saying that 45 is 45 radians, not degrees. So make sure your calculator is in the right mode for the type of angle that you're using. All right, let's move on to number 7. Number 7 says a pilot flying an airplane at an altitude of 1 mile sights a point at the end of a runway. The angle of depression is 3 degrees. What is the distance d from the plane to the point on the runway round to the nearest tenth of a mile? Okay, first things first, let's draw a picture. We have a plane that's in the air 1 mile of altitude, so 1 mile off the ground. So here is our plane. I'm not going to attempt to draw an airplane. Here's our plane, and we know that it's flying at an altitude of 1 mile off the ground. All right, and then it says it sights a point at the end of the runway. So if it's trying to land, the runway is down here. Okay. Notice that this is going to make a what kind of shape? A right triangle. So that's good. Okay. It says the angle of depression is 3 degrees. Okay, so angle of depression can be tricky. With this problem, we had an angle of elevation because we go up to create our angle. But here, we're starting at the plane, and we want to look down to our runway. So that's going to be the angle of depression. So what I like to do is just draw a horizontal line out from what we're talking about, and then this is our angle of depression. This is our 3 degrees. Okay, so it's when you start where we are and go down. That angle is the angle of depression. Okay, and then it says, what is the distance d from the plane to the point on the runway? So we want to find this distance from the plane to the runway. Okay, so we have this triangle. We know this is 90 degrees, but we don't know anything about these other side lengths, except that we do. We know that this up here creates a right triangle as well, so that means this angle inside must be 90 degrees minus 3 degrees. This must be 87 degrees. All right, so now we know some information. All right, so this is our angle. What do we know? Well, we're trying to find the hypotenuse, and we know the side adjacent. All right, so do we have any trig functions that deal with adjacent and hypotenuse? The answer is yes. Which one is it? That would be cosine. Cosine is adjacent over hypotenuse. So that means cosine of 87 should be 1 divided by d, sorry. Cosine of 87 degrees is 1 divided by d, adjacent over hypotenuse. All right, and so then we just have to solve for d. I'm going to move this over so I don't have a fraction anymore. And then divide the cosine of 87 degrees. All right, so 1 divided by 87 degrees, it says we want to round to the nearest tenth of a mile. All right, so calculator, make sure your calculator is in degrees here. And we're going to do 1 divided by cosine of 87. All right, and I'm getting 19.1. miles. All right, so in this section, make sure you can evaluate trig functions of acute angles, so those angles that are less than 90 degrees, so the ones that will be inside of a right triangle. Also, are you able to use trig identities? All right, so we know that we have reciprocal identities, so sine is the reciprocal of cosine. Sorry, sine is the reciprocal of cosecant. Also, we had some cofunction identities. And also, can you use trig functions in applications like we just did? All right, and if you have questions, definitely ask me in class.